be seeing a single slide, which says GitOps is likely more than you think it is. So I'm going to spend about the next 35 minutes or so, or maybe a little less than that, about 30 minutes, chatting with you about this topic, just going through the slides, and then I will try very, very hard to leave some time for questions at the end. So without further ado, let me see if I can get my mouse into the right place. There we go, advancing slides. Thank you for the intro in the background. I'll tell you a little bit more about myself. I have been doing this for a long time. I've been in the industry for about 30 years, graduated college, got a degree in computer science. I was one of the lucky ones that I discovered computing when I was in high school, which was pretty phenomenal back in 1981 to have computer programming available at my high school. So I was very, very, very fortunate. I've spent, that 30 years, really, I came from it from the developer side. I didn't come from the operations side, so I never really ran software in production. That is relevant to the talk here today because I'm going to be talking about ops. When I was at Pivotal, I learned that developer platforms are not just around cutting code, but that they are these days all about bringing code all the way to production. So I do consider myself as much of an ops person and a developer, so a DevOps person, as I am just a pure developer. In terms of the technology that I've been working in, I've been working in web architectures for probably closer to 20 years, cloud native for a decade, Cloud Foundry for more than 8 years, and Kubernetes for probably closer to 5 years. And as was mentioned in the intro, I have written this book called Cloud Native Patterns, which is a book that is targeted at the application developer and the application architect to teach the patterns that allow you to build your software so that it remains resilient and running well in this highly distributed and constantly changing environment that we call the cloud. So that's what we call cloud native. But what I'm going to talk about today is GitOps. You have likely heard the term. I joke around that it's the center square on the buzzword bingo card these days. If you haven't looked at a bingo card in a while, the center square is actually the free square. So I mean that quite intentionally, that you are going to hear the term GitOps. It's almost like getting a free square in the center of the buzzword bingo card. I'm not going to go over all of these things that are on this very wordy slide, but there are a number of things that GitOps promises to deliver. At the core of that is really around developer productivity. We want to make it so that the developer isn't burdened with a whole bunch of toil, a whole bunch of things that can be done repeatably. But you'll see as I go through the presentation that it's quite important that the automation that I'm talking about here is done in a particular way. And that's really going to be the punchline of the talk. If we do things in the right way, then we gain benefits of things like reliability. We also gain benefits that our auditors are going to love because all of our changes are going to be tracked and be auditable. It's also going to allow us to survive outages far, far better than we did in the past. Things like a disaster recovery become almost trivial if you're doing GitOps in the right way. And so given that these are the values that we want to achieve, it is, again, very important that you do GitOps the right way. And so that's the question that I want to pose here, and the question that I want to answer over the rest of the time, which is, so what is that right way that you keep speaking to? Now, at a very, very high level, you can think of GitOps as the following. We're going to store our code in our configuration. And when I say code, I mean infrastructure as code, not just application source code. I'm going to store that in some type of a repository like Git. And then as a result of storing that, I'm also going to apply some automation against that code. That's part of the element of infrastructure as code, is that we have automation. And then that automation is going to result in my application being up and running in some type of a runtime environment. Now, you'll notice here that I'm using the Kubernetes logo, and I will be speaking about Kubernetes throughout the presentation, but understand that GitOps is a pattern that applies across any type of runtime environment. So you could be deploying things into virtual machines, you could be deploying things onto bare metal. There's a whole host of runtime environments that are supported. And then, of course, GitOps also ascribes to this notion that you are leveraging the user interface that Git provides. So things like GitHub or Bitbucket or GitLab. And if you thought that this was what GitOps was, you'd be right. It is kind of at 10,000 foot view. That is effectively what GitOps is. It's leveraging versioned immutable stores like Git, and it's leveraging automation. But as it happens, the details matter. And how we do those elements, how we leverage Git, how we implement our automations, that's the secret sauce of GitOps. And I hope that by the end of this talk, you'll understand what I mean by the importance of that. Now, for those of you who know me, I'm a bit of a propeller head. You studied computer science. I also studied, logic and philosophy and, mathematical, theory of computing. And so I like to do derivations. I'm one of those insane people that likes proofs. And so I'm going to derive a bunch of these values rather than starting with, hey, here's the principles of GitOps. I want to derive them for you. I want to look at it from a use cases lens so that you really understand why those patterns are important, not just what the patterns are. So we are going to talk a great deal about some GitOps patterns throughout this conversation. So I'll start with what I think is probably pretty well understood, although there's even in this first diagram, there's a little bit of a nuance. You'll notice here that I have what I'm calling the developer and the DevOps engineer. So she is cutting code. And increasingly these days, she's also responsible for keeping her applications running in production. So she's responsible for the entire software development lifecycle from code creation all the way out to running things in the dev environment, staging environment, and the production environment. Now, I already mentioned configuration as code. So what you see on here is you see the Git icon in two different places. You see it down here in the source code. So in the lower portion, you see the arrow that is marked source code. And yes, the developer is going to be cutting code and she's going to be committing her code into that source code repository. But as we start to automate more things, we're also going to take our application configuration and put that in a Git repository. Best practice number one, those are two separate Git repositories. And I think you'll see why as we go through some of the presentations. In a nutshell, I mean, the first thing you have to realize is that there isn't just one environment that this application is going to be deployed into. And there are going to be configuration differences between dev and production. So you do want to separate your source code from your configuration code. Now, you'll notice on the source code that we have continuous integration, so something like Jenkins or GitHub Actions that are running and creating these days containerized, images. So it's running through the unit tests, it's building the source code. Let's say you're doing Java, it's building the Java into Java bytecode, and then it is packaging that up as a Docker image. Then what we're going to do is the goal then is to take the configuration along with those Docker images, apply some automation, and get it running in the runtime environment. Now, what's the first most natural way you might think about taking this automation all the way out to delivering into the runtime environment? And the first place that most people started thinking about is right here at continuous integration. I've already got automation there, so can't I just add something, add another step to my continuous integration pipeline that does the deployment? Well, I'm not good at keeping punchlines in check. The answer is no, but let me explain why. So continuous integration is a mature model. Hopefully you're all doing it and it works. It's been matured over the last 10 or 15 years. And it has absolutely upped the game of software developers. So it allows us to have this very iterative process. There's mature tools. There's a whole community of practice that knows how to do this. And so let's start there and say, all right, well, let me then just add deployment into that pipeline. So I've got build, I'm deploying things into Git, and then I'm doing a deployment out into my development environment, and then doing a test in the development environment, and then circling back into the IDE. So can't I just have continuous delivery as a part of that process? And the answer, of course, I already told you is no. But let me explain why. Application deployment should be separate from CI. And here's just a few reasons. You see the ellipses at the bottom. These are just the top reasons, and there's many more as well. Number one is that in quite a number of organizations, there is a need for separation of concerns. Developers, they release software packages, but operators do the deployment. In regulated environments, these have to be two separate things. So the application developer is responsible for that CI cycle, but the deployment has to be separated from that. So there's sometimes regulatory reasons. Now, I already mentioned that there's often multiple deployment environments. So you can't just have one deployment, and you don't want to integrate a whole bunch of different deployments into your CI cycle. You need to handle these many deployment environments through a specialized process. And then finally, recreating a deployment. For example, I have my deployment running. I have some kind of a disaster and I need to get it up and running in a different region within AWS, for example. I shouldn't have to redo a build. I shouldn't have to go all the way back to my CI system. I should just be able to do a deploy. So the punchline here is that we definitely want to keep deploy separate from the CI process. And one of my big pet peeves is that there is no such thing as CI/CD. It's not one word. There's CI, absolutely valuable, don't want to touch that. And then there's continuous delivery. All right, so back to this picture, CI is not our answer. Instead, what we're going to do is we're going to separate out CD. Now, one of the things that's happening is that there's quite a number of people who are experimenting and using tools that have a centralized CD system. And that centralized CD system is responsible for pushing things out into the deployment environments. Now, that centralized CD system can scale to the multiple environments like we've talked about here, dev, staging, and prod. But you know what? There's still a problem here. There's a security problem. And if you haven't heard and looked at what was at the root cause of the SolarWinds outage, it was a compromise in the software supply chain. And so what we're talking about here is a software supply chain. If that centralized CD server is compromised, every single one of your deployment environments is compromised. That's the way that malware can effectively get into not only your dev and staging environment, but worst of all, into your production environment. So one of the things that we consider a critical to the GitOps methodology is that we're going to turn those arrows around. And we are going to say each runtime environment is responsible for its own destiny. It's responsible for pulling in the configuration that it needs. And so the pull-based model is really important. But hang on a second. I've got the CI process that's happening on the left-hand side, and I've got this pull model on the right-hand side. How do I then know when to pull? Well, the good news is that you don't have to know when to pull. What we're going to do is we are going to do that pull continuously. And this is a key pattern of GitOps. This reconciliation, this infinite loop that is constantly looking for updates, constantly looking for reconciliation, that is a core pattern. And so if we now, I'm just going to simplify the picture. We've got a runtime environment that is constantly looking for changes that it needs to pull into its environment. If we take that as a core pattern, this enables a whole bunch of additional interesting patterns that provide great value to our entire software development lifecycle. Pattern number one, drift detection and remediation. So one of the key principles of GitOps is that we are going to store in Git the entire representation of my runtime system. That means that if I need to stand it up, I just spoke a moment ago about Amazon has a regional outage and I need to stand my software up in a different Amazon region. Well, I've got a complete representation of that in a Git repository, and I can just deploy that into the new environment. Well, that only works if my runtime system doesn't drift from what is in the Git repository. And these days, I like to call it the modern day equivalent of SSHing into a box and making a change, is in a Kubernetes environment, when you run a kubectl apply against the Kubernetes cluster, you are now changing something in the runtime environment that isn't captured in Git. And so what this reconciliation loop does is it's not only pulling things from the Git repository into the runtime system, it's also constantly monitoring the runtime system and making sure it doesn't diverge. And if it does diverge, you can do any number of things to remediate. You can either have what's in the Git repository reapplied, so you can pull what's in the Git repository and reapply that in the runtime environment, in essence undoing what was just done with that kubectl apply. Or you could say, well, wait a minute, I'm going to take a more conservative approach and assume that somebody needed to do that for a reason, but I'm going to notify people all the way up the chain. And I'm not going to allow any additional changes, let's say, to the repository until we have brought these things back into alignment. And I'll talk a lot more about that alignment in just a moment. So drift detection and remediation is a very, very important attribute. Now, the next thing that I'm going to talk about is, remember here, if you take a look in this diagram, you see you have the image, you have that the CI process is building, and you have the application configuration. The application configuration is pointing to a specific version of that image. Now, if the developer changes her source code and it causes a new CI build to run, she would now, based on this picture, have to go into the application configuration repository and bump the version number. But you know what? GitOps enables a pattern that automates that as well. So what we see here, I've just moved that a little bit over to the left so we have some space to play with in the middle. Right here, you see application configuration. Again, at the moment, this application deployed into my runtime environment is pointing to version 0.0.1 of my application. It's that container image. Now the CI system is going to run and it's going to generate version 2. What we do with GitOps is that we have a convergent mechanism. We have a loop that is constantly running and watching that image repository. And when it detects that you have bumped the version in your image repository, it has another loop that says, I see now that I can write that version number into my application configuration. So you can see here that it bumped the version number from 0.0.1 to 0.0.2. As soon as that is committed into the Git repository, another reconciliation loop is run that pulls that into the runtime environment. So you see how these convergent systems brought together into a whole set of patterns allows me to optimize my developer workflow. And that is really, really powerful. Another pattern, environment customizations. Let's go back to the scenario where I have dev, staging, and prod. They have very similar configurations, but their configurations aren't exactly the same. In my development environment, I'm maybe testing something with 2 replicas, but by the time I get in my staging environment, I'm going to test with 50 replicas to make sure that I can scale. But then in my production environment, right now, I only need capacity for 10 replicas of my application. So there's differences in the application configuration. Well, GitOps supports this by allowing you to specify a base configuration and specify specializations against that base configuration. So again, you can see here that the number of replicas is different across the different environments. Now, as a part of that process of pulling things into the runtime environment, we can apply these customizations to each of the various environments. So we take the base configuration, we specialize it, and then deploy it into the appropriate runtime environment. Okay, so you can see these are all elements of continuous delivery. So that continuous delivery process is, again, reconciliation based. So this is where we were. What we said was, okay, we are going to pull the deployment out. But you know what? I've really been talking about delivery. I've been talking about delivering things into the Kubernetes cluster.
Is there something else I can help with?
Forgive me. I woke Siri up somehow. Let's see if I can get rid of her. Where is my mouse? Ah, there we go. All right. Let's see if I can get through the rest of this without waking her up again. So I've been talking about delivery. So everything that I talked about was about delivering from the Git repository into the Kubernetes environment. But we also want to get all the way to deployment. And so the question that I would pose is, have I talked really about deployment, or is just Kubernetes doing the magic deployment? Well, we're getting there. We're almost done with deployment. So we're going to look at one more pattern. Going back to this example, remember image update automation. To drill into the details just a little bit more, again, what I was just doing so far, when I did that Git pull, the Git pull was pulling from Git down into my Kubernetes environment. What was really happening there was that I was pulling that configuration and I was storing it in the local data store of the runtime environment. For those of you who are not familiar with Kubernetes, that local data store that stores all of the configurations for that runtime environment is a technology called etcd. And that's what this logo is that you see right here. That little blue with it looks like it has two eyes, it looks like a little bit of a robot. So I've pulled things in and I've dropped things into that repository. Well, you also need something that is going to take things from that repository, that local repository, local to the runtime environment, and get it running, get the actual instances of the application running in production. And in a Kubernetes setting, those things run in what are called pods. Now, Kubernetes has built in this reconciliation pattern. So that little arrow loop that you see there, that's built into Kubernetes. So when I delivered things, when I did that Git pull and dropped things into Kubernetes, then Kubernetes automatically took care of deploying things into those production environments. Now, if you're running in an environment that doesn't have some of those controllers, those reconciliation loops built into it, then you're going to have to source those from somewhere else. The good news is that these patterns that I'm talking about around reconciliation are becoming so popular that there are all sorts of reconciliation-based, kind of infinite loop-based technologies out there in the open source that will serve things other than just Kubernetes. But one more pattern that I want to talk about here is that Kubernetes has its way of doing deployments. Another technology that you might have heard about is you might have heard the term progressive delivery. Progressive delivery says when I go from version 1 to version 2, as you see on this slide here, I'm not going to replace all of version 1 with version 2, cross my fingers and hope that all my testing was good enough that nothing's going to go wrong in production. I'm going to do so incrementally. I'm going to do so very, very carefully. And so what you see here on the screen is a more incremental way of doing that deployment. I have two versions. I have two instances of version 1 running, and I'm going to spin up one bit of version 2, and I'm going to direct 5% of my traffic to that. If all goes well, I'll incrementally bump that up to 10, 20, 30, and then ultimately up to 50%. And in this particular strategy, I say, if I get to 50% and everything is looking good with version 2, then then and only then am I going to take version 1 offline. If anything goes wrong in these first 2 stages, then I'm just going to revert back to version 1. Well, this progressive delivery, and there's a number of different styles. In fact, I think I might have a slide that shows you, I might have taken that out, in fact. We have this notion, this is what we call a canary style deployment. Then we also have, more of a A/B testing where you allow V1 and V2 to run indefinitely next to each other. You also have blue-green where you start directing traffic over to V2, but you're still serving back to your customer 100% of the traffic from version 1. And once you've validated that version 2 is working well, you're not returning any results, then you make a full scale. And there are reasons for doing that as opposed to the canary progressive rollout. Now, the good news is that these progressive rollouts, you'll notice here that there's, again, this kind of icon that shows this reconciliation. It turns out that we can apply those patterns within, we can insert that into our software delivery lifecycle that we have here. So I can insert another reconciliation loop here that does that progressive deployment. And yes, here's the slides that I was talking about. There's an open source project that my company, Weaveworks, had originally created, but has been donated to the Cloud Native Computing Foundation called Flagger, that implements these various release strategies like canaries, A/B testing, blue-green, and so on. Okay. Whoa. That's a lot, right? This is pretty darn complicated. But let me summarize it in a way that I think is going to make it quite understandable. What GitOps is about is that we are going to store our configuration in Git. I haven't emphasized it yet, but I have emphasized this reconciliation. In order for that reconciliation to work, that needs to be declarative configuration. It needs to be a declaration of what I want running, not a set of instructions on how to get there. It says, I want 3 instances of my front end application running. I want 5 instances of the back-end services running, and I want 1 instance of my database running. You're declaring what you want running. What we do then is we take that declarative configuration and we use a number of delivery controllers, that's these infinite loops, that are going to deliver things into a runtime environment. Then our runtime environment needs to have some runtime controllers that are constantly reconciling, that stand up your application in production. This here, if we go back to the original diagram, I talked about storing code configuration, I talked about automation, and I talked about it running in the runtime environment. And that, in a nutshell, and there's a user interface, is what GitOps is. GitOps is continuous delivery, constantly reconciling, plus continuous operations, constantly reconciling, and those 2 things in combination are GitOps. Now, one final summary to bring it all together in the same picture. And this picture is going to look very similar to the first one that I started with, but it's going to call out what those, remember I said it's not just Git and automation, that there's some special secret sauce ingredients. It's going to be very clear on this slide. We have a runtime environment. Our goal is to get our applications running well in that runtime environment. Again, I'll emphasize that Kubernetes is just one example of the runtime environment. That runtime environment is the only real representation of the actual state of your environment. It's what's running. That's the actual state. On the opposite end, we have developers and DevOps engineers who are responsible for keeping things running properly in that runtime environment. How do they do that? Well, they are going to store their declarative application configuration in a versioned immutable store. like Git. And here's the important part. They're not storing things in Git and then going to some console to apply things. This is the interface for operations. They're not going to a console and clicking through some panes. They're not running things at the CLI. They are using Git as the interface for operating things out in production. As they are using that interface, there's automation that is going to make it so that when you issue a pull request, it's been reviewed and it's been merged into your main branch. That is the trigger for this automation. But not any automation is sufficient. It needs to be this convergent automation that I've been talking about all along. So it's constantly reconciling. So you can see here that it says desired state and actual state. It's constantly converging those things. And then finally, we haven't talked about it a lot, but there is a loop that circles back because there are certain either automations that happen in the runtime environment, or there are break glass scenarios where you in fact do need to go into the runtime environment and very quickly make a change and can't afford these reconcilers to catch up. But the important thing is that when those things happen in the runtime environment, if they're legitimate, we need to have an automated way of capturing those things back into our configuration repository. So a drift between the runtime environment and the desired state in the repository. So finally, I just want to show you this kind of review of the patterns. I'm not going to go over them again, but these are a set of GitOps patterns that I covered throughout the presentation. And with that, I thank you for your attention. I hope this was helpful and that you were able to learn a little bit about what GitOps is throughout the last half hour. And with that, I think I'll stop sharing my screen and see whether there are any questions. Hello.
Hi. Thank you so much for that presentation. A lot of information to digest.
Yep.
Really great graphics, by the way.
Thank you.
It was very visually helpful.
Good,
I really
good.
appreciate that in presentation. We do have some time for questions if anyone wants to drop those in the chat. At the very beginning of your talk, you got a question immediately. What is the difference as a developer from 30 years ago and now in terms of mentality, daily life, etc.?
Yep. So it's interesting. There are quite a number of differences. So I'll share a little bit of my personal story. So I started my career in aerospace, and I was working on embedded systems, missile systems in particular. So what I did then was I wrote code that ran on one processor, on one computer. It wasn't even a multi-processor architecture. So I ran code. I knew what was going to run, and it ran on this machine, and there were no other external influences. Of course, it was image processing, so I had images coming in from the sensor, but it was really kind of this single computer that I was programming to. And then when I was in the university, and I went to school, and then I worked for a while, and then I went back to school, started a PhD, never finished it. But I remember back then, this was kind of late 80s, right around 1990. Distributed systems was still very niche. So distributed systems being lots of computers, right? And they're all working together to solve a problem. It was pretty niche. And I remember when I went back to work, I worked on a project that did a little bit of like distributed system stuff. But most people, like distributed systems was like this black art that most people didn't understand. Today, thanks to the internet, every single one of us is a distributed systems engineer. And so we are solving problems that 30 years ago were considered the problems that only the smartest of the smart were solving. And so y'all are distributed systems engineers. And so the problems that we're solving are far, far more complex than they were 30 years ago. Now, thankfully, the technology has evolved to support us in solving these more complex problems. Back then, we didn't have, CI. We didn't have container images. We didn't have ways of deploying things across these distributed systems in a way that's scaled. So fortunately, the technology has evolved to support us as developers to be able to do that. And then the last thing I'll say is that certainly more recently, in the last 5 or 10 years, it's definitely become the thing where back when I was a developer at the beginning, I developed my code, I tossed it over the wall. I said, I'm done. And I went to have my party, and I left the operators with the burden of making sure that this worked. And that has changed dramatically. Increasingly, we as developers are responsible for running things in production. And you know what? It works better that way. Makes everybody happier.
I love that perspective of that we're all distributed engineers. It's not really something that I think about in my day-to-day life, but it's nice to have it called out.
Yep.
Navani just asked a question. In your opinion, how much should an application developer learn about GitOps?
So that's a really outstanding question, always outstanding questions. So there's a couple of models that we ascribe to. What I see, the company that I work for, we work with a lot of large organizations like, the financial services companies or the insurance companies or the telco companies, where they have literally thousands of developers that are working. And in those scenarios, the way that those organizations are working on GitOps is that they are taking what we call their platform teams. Their platform teams are the ones that are providing the developer environments and providing the tool set to the developers. They are the ones saying, we will learn GitOps. We will provide to the developer an environment where all they have to do is that push into Git. All they have to do is that I've changed my code, and that's going to cause the CI to kick in, and it's going to create a new container image. And you remember that image update automation that automatically updated the application configuration? And when that happened, it propagated all the way out. The developer doesn't need to know about all that magic that's happening at the back end. What we need to do is give them the observability tools, and that's what these platform teams are doing, is that they're implementing the GitOps patterns so that the developer can just cut their code, compile it, and then get a dashboard that says, okay, here's how it's running in production. Now, if you're in a smaller startup, then you should absolutely learn the GitOps practices, because you're probably responsible for a lot more of the developer tooling than you are in a large organization like that. So
very true. Yeah. I think we would have time for one more question if anyone has anything else before we wrap up this session and go on to our next set of talks.
Yeah. Well, I thank all of you. Please chime in with another question if you've got one, but I thank all of you. And hey, girl power, girls, women who code, we all rock, right?
Thank you so much for being here and participating in our conference and giving this talk. We really appreciate it. And we couldn't pull off a conference like this without talented people like yourself.
Thank you so much.
With that, I encourage everyone to go check out the next session. Thank you all so much for hanging out with us. And thank you so much, Cornelia, for presenting.
See ya.